So this is the first problem of the Div 2 contest, Ballon d'Or. It says that Leo has already won Ballon d'Or 8 times. So he's really impressed with it, is he? And Leo has an array A of n integers. Each element of this array is either 1 or 2. He wants to figure out if the product of all the elements of the array can be written as an eighth power of some integer, that is k raised the power 8 for some integer k. We have to print yes if it is, if we can, otherwise we have to print no. So the problem is pretty simple. We have been given an array of size n, and all the elements of the array would either be 1 or 2. So array might look something like this. And what we have to tell is whether the product of all the elements, first of all, whenever you see a problem in which you have been given an array, or like basically you have been given all the elements and you have to do something with the product, keep one thing in your mind, like it can be product or sum of all the elements or anything which can be calculated from these elements. Since these elements have been given to you, if the problem says that, um, maybe first of all we can just complete the problem and then talk about it. Let me explain the problem from the beginning once again. We have been given an array of size n, and we have to tell whether the product of the array A, basically all the elements of the array, can be represented something like k raised the power 8 for some integer k. Like k is an integer here. Whether it is possible or not. So our answer will be either yes or no. Let me give you one example. Like if you see, in this example, the product of the array is coming out to be 8. So is it possible to have it represented as k raised the power 8 for some um, integer k? The answer is simply no, right? Because 1 raised the power 8 turns out to be 1, and 2 raised the power 8 turns out to be 256. So if you represent 8 as k raised the power 8, then k will be something between 1 and 2, which will not be an integer. So is the problem clear? Like, is the problem clear what we have been given and what we have to do? Angans, your approach is absolutely correct. Okay, so if the problem is clear, let's see. The observation which I wanted to tell you here is this is a really generic thing which you can apply at a lot of places. We have to do something like we have something to do with the product, right? We have something to do with the product, and we have been given an array, and we can find the product from that array. So this is one thing which you should keep in your mind, that product will be constant for a given test case. Since the elements of the array are never changing, the product of the array will also never change. Now, having this observation might not really be very helpful for you for this problem, but this is something you should get in your mind. And the reason I discussed it here is because it's good to just learn about new standard observations. So see, since I have been given this product and it would be constant, um, somebody is asking, can I repeat it once again? Okay, so let me repeat it. The observation which I said here is, we have been given an array, and from that array you are deriving something. Basically, you are deriving a product of all the elements, and then you have something to do with that product, right? And you know that whenever we see a problem, what we try to do is just make it as simple as possible so that we can solve it easily. So this is one observation you could have you could have seen here, that the product of the array depends only upon the elements of the array which are never changing. So for a given test case, basically when you have been given an array, the product would always be a constant integer which would never change. So if you can solve a problem like, given an integer p and you have to tell whether this integer p can be represented as k raised to the power 8 or not. This problem would be equivalent to the given problem. Does it make sense? By the way, this thing is not really required here. Like, you don't need to have this observation here. Uh, like, this observation won't really make the problem simpler. I just wanted to discuss it because this is a really good thing to learn. Okay, so the idea here is, since you have only two elements, you have like only two kind of elements, either one or two, right? Um, Whatever k raised to the power 8 is, let's say if I represent it as, sorry, let's say if I can represent the product of all the elements p as k raised to the power 8, then it should look something like this: k into k into k into k 8 number of times, right? K raised to the power 8 is nothing but k into k into k 8 number of times. Now, all the ones which you are getting, all the ones which you are getting, they won't really affect the value of p or k, anybody of them, right? The value p will never affect any of these values. So this k can be affected by only this guy 2, right? 2 is basically the number of times 1 is coming in the array does not really create any difference. But the number of times 2 has been coming up in the array does matter. So let's say if 2 is coming up 20 times in the array, then the product of the array will be 2 raised to the power 20. And it does not really matter how many times 1 is coming. Maybe 1 is coming up 100 number of times. The product will still remain the same, right? Even this thing was not really required. You just had to observe you just this much, that the product of the array depends only upon the number of times 2 has been coming. The number of times 1 has been coming does not really matter. So if this 2 raised to the power 20 can be represented as k raised to the power 8, then it would be really good. And I think that now this is quite intuitive, that if the thing in power is divisible by 8, in that case, you will be able to represent the uh, given product as k raised to the power 8. By the way, how many of you are with me right now? Or do I need to re-explain the things till now? I was just willing to show some more observation, but I think that it's not really applicable here. Okay, okay, great. So let me still recap it. The main idea for the problem, like everything we have discussed, like most of the parts which we have discussed in this problem till now are not really explicitly for this problem. There were some generic things which I do think about when I see problem. The basic idea in this problem was, the array A has been given to you, which comprises of only two kind of elements, that is either one or two. The product of the array, let's call it as PA, the product of the array, would have like would actually be equal to 1 raised the power the number of times 1 has been coming into 2 raised the power the number of times 2 has been coming. Now 1 raised the power anything would still remain 1, so you can just ignore this thing. The product of the array would now we can say that the product of the array will be equal to 2 raised the power the number of times 2 has been coming, and we want to represent this thing as k raised the power 8. Now from this part, I think that it should be intuitive that if this count of 2, let's say if this count of 2 is divisible by 8, let's say 2 raised to the power 24, it is something like 2 raised to the power 24, then you can call it as 2 raised to the power 3 into 8, and then you can call it as 2 raised to the power 3 raised to the power 8, right? But if it was something like 2 raised to the power 20, then for representing it as k raised to the power 8, it would be 2 raised to the power 2.5 into 8, which is 2 raised to the power 2.5 raised to the power 8. And this thing would not be an integer. it won't be an integer. So, like from this, you can actually conclude that this power, or basically the number of times 2 has been coming, should be divisible by 8. So, what you can do is just count the number of times 2 has been coming and then say that it should be divisible by 8, then print yes, else print no. Is this clear? Or does anybody have any doubts? Can we get product of all elements and group it? It's okay. So somebody is asking that can we actually find the can we find the actual product? Can we just find out the product? Where yeah. Can we actually find out product of the array and then root it by 8? If it comes out to be an integer, then the answer is yes, else no. So yeah, the idea is correct, but the problem is, let me just look at the constraints. Yeah, there can be 2 into 10 raised to the power 5 elements in the array. So let's say if all the elements are equal to 2, then the product of the array will be 2 into 10 raised to the power 5, this much, which is a very huge number. You can't really store it into an integer. And secondly, there is one more problem. Even if this PA, let's say if it was coming out to be some integer, let's say that there were only a few number of times 2 was coming in the array, and the product of the array was storable inside a long long, still, like rooting it with 8 might not really give you an integer. It might give you something like 3.999 instead of 4 because of precision error. So this it still might give you wrong answer. So this is, by the way, this is a good doubt. You should get this kind of doubts. Um, and I hope that it is clear that why your approach will not really work here. Suppose if we have to think in a way that they were things like data A3. Okay, so Abhinav was having the same doubt. I hope that the doubt is clear now. Does anybody have any other doubt? Have we discussed A comma B? We are starting from div to A. So this is the first problem which we have been discussing right now. We are going to tell something about the type of problem. I didn't understand what are you trying to ask here. How to check if the root is an integer or not. For checking whether the eighth root is an integer or not, um, maybe something like, maybe you can do, like I have never tried it, but I do have some idea. First of all, you will not directly get an integer. Let's say if you are getting a perfect integer, which is 4, let us say 4.2, and you want to check if it is an integer or not, if it is, let's say, stored inside a float. You can just do its ceil and you can do its floor. Basically, round it up and round it down. If both of the times you get the exact same value, in that case, it is an integer, otherwise, no. But for something like 3.9999, since we know that we might have got some precision errors, generally a bit more complicated thing is being done, which is just try to find out the absolute difference between this 4 and this number. And based on the like amount of precision error which you are ready to uh, leave, you can decide whether to call it as an integer or not. When you started explaining last 3 digit divisible by 3 is India. Hello sir, so the offer, but can you clear one thing please? Student level 1 not understand. Cam, sorry but try. I will discuss this thing after, like I will help you after the session if I can. For this thing, it is not really related to PCB right now. Does anybody have any doubt related to the problem right now? I think that it, there are no more doubts right now, at least no more relevant doubts. Okay, so let's move on to the code thing. Yeah. Hello. Okay, let's see the problem. By the way, for those who have been seeing my template for the first time, you don't really need to worry about this. Just forget about it. You don't really need to worry about these DBG statements. Like whenever you see something like DBG, CRNDL, or debug, just forget about it. And this thing you see here is is called a lambda function. This is similar to the normal functions you create. The only difference is that it has been created inside the function itself. So treat it as a normal function which has been returning an integer, or maybe you can just consider it as a bool. So you don't really have to worry about anything else. Just see that inside the for loop for the test cases, I have been calling this function and have been getting some true or false as the answer. If I get true, then I will print yes. Otherwise, I will print no. So just focus on this part for the test case. For each and every test case, I have been taking up the inputs, basically the number of elements and the array. Then I have been calculating the frequency of 2 in the array. And then I have been just returning whether the number is divisible by 8 or not. So if the count is divisible by 8, then I would print yes. Otherwise, I will print no. So is it clear? Please explain this part. This is something actually uh, you can just study about it from GFG. As a brief, I can tell that if you are having this ampersand here, then whatever variables you declare here, let's say if you declared const int n equal to 100 here, then you can actually use that variable here also. You uh, you will be able to access these elements here. And if you don't include this ampersand, then in that case, you cannot access anything outside the function. Yeah. By the way, you can just search about it on GFG. They have a really good article for lambda functions. You will be able to understand it. So shall we move on to the next problem? Or does anybody have any doubt related to this problem? Somebody was asking, you have not written for one. I think that you are asking that what if the product is one? Is that what you are asking or something different? Or are you asking that I have not calculated the frequency of one? Um, yeah. The reason we have not calculated the frequency of one is because it was not making any difference. And I thought the product will not overflow because this is different. See, n will not overflow. Like the sum of n will be less than equal to 2 into 10 raised to the power 5. But in a single test case, since there can be n elements, the product might go as large as 2 raised to the power n if the array size is big. So it can overflow. Let's move on to the second problem now. Um, just 1 second. Let me put my laptop to charge. Okay, so this is the second problem. Alice has a binary string s. Let me just talk about the important part here. Okay, so the problem says that there is a string s, binary string s given to us. S will be a binary string. A binary string means that all the characters would either be 0 or 1. On their turn, like Bob and Alice are playing a game and they will take alternative turns. On their turn, a player will have to choose a palindromic cyclic substring of length greater than 1. Now, what is this palindromic cyclic substring? This is something they have not told here. They have told it here. We will see it. So just see, like the very first step is choose a palindromic cyclic substring. We will have some condition for that. And in case if the player cannot choose it, then the player will lose. Otherwise, if the player can choose it, then first of all, he will have to choose any one of the palindromic cyclic substrings. and then he will have to choose some character within this palindromic cyclic substring and delete it from S. And this operation will reduce the size, or basically the length of the string, by 1, because we have got rid of one of the characters, right? And the definition of cyclic substring is here, palindromic cyclic substring. Before that, there is one more thing. If allies goes first and both players play optimally, who will win the game? This is something we have to tell. And here they have defined that a palindrome. I think that you already know about palindrome. The numbers which would be read the same in forward and backward. And we say that a cyclic palindromic substring is a string S, sorry, of a string S of length n is defined by two integers L and R, where if L is less than R, then this is a normal substring. Otherwise, if L is greater than R, then this is a cyclic substring. Basically, let me show it visually. A substring like this, 101, is a normal substring from S. But if you pick up the characters in this way, that you pick up some characters from the end and some characters from the beginning, and you call it as 1001, 1001, this is a cyclic substring. And if at the same time, like while being a cyclic substring, by the way, a cyclic substring can be a normal one also. Like this can also, we will include this string as well as a cyclic substring. So if along with cyclic substring, if it is a palindrome also, then we will call it as a palindromic cyclic substring, or maybe different. Yeah, palindromic cyclic substring. We have been told that in case if there does not exist any palindromic cyclic substring inside S, then the player will lose. Otherwise, that player will have to choose a cyclic substring, sorry, a palindromic cyclic substring, and then he can delete any character from it. So basically, choose a cyclic substring, palindromic substring, and then delete one of the characters. It's up to you which character you delete. And we have to tell that allies will play first, then Bob will have the turn, then allies, then Bob, then allies, then Bob, and so on. And we have to tell who will win the game. Who will win? So, is the problem
The
clear? Like the problem statement?
not clear so much. Like, what do you mean by palindromic cyclic substring?
Uh,
May you explain it again?
okay. Did you understand the cyclic substring?
Cyclic substring, I know. I can choose from last and first.
Yeah. If this substring which you have chosen is a palindrome as well, like this is
Okay,
a palindrome, then it
okay,
would be a palindromic cyclic substring.
okay, okay, clear.
Yeah.
And and
And
next.
this does not necessarily have to include the last and the first elements. Even if you have something like this, it is
Mm-hmm,
also going to be considered as a palindromic
mm-hmm.
cyclic substring.
So Alice and Bob will delete that substring or one element from that substring.
They will delete one element from that substring. They have
Okay,
mentioned it here that they will have to choose a palindromic cyclic substring first of length greater than 1.
okay,
Yeah, by the way, this is also a palindromic cyclic substring, but it is not having a length greater than 1, so we can't choose it. And then they will have to choose some character within this substring and delete it from S. Since we are
o-
deleting one character, the length of the string will reduce by 1.
o-
Okay, so guys, now is the problem clear? Or does
Uh,
anybody have any doubt here also?
Excuse me, how will be a two character be a palindromic cyclic substring?
Can you repeat again?
How will a two character like integer will be a palindromic cyclic substring? Like it is given character should be greater than one, but that will include two, right? So how will be that considered palindromic
I
cyclic
think that
substring?
I still did not get what did you want to ask. Were you asking that how will I verify, like, what is your doubt?
No, over here like you're considering three characters for your substring. Like
Okay.
for example, 1, 0, and 1, the middle one.
Okay. This.
Yes, yes.
Yeah.
But in the question, it is given that they can consider any substring which is greater than 1,
Yeah.
right? So that would include two characters also, two integers also. So
Yeah.
they can consider 0 and 1 also, and 1, 1. So how will be that palindromic?
Yeah. They like this is also palindromic, right?
Yes. Okay, okay. Sorry,
Yeah.
got it.
This is also palindromic. So like
Okay.
okay. So any more doubts? Let me see. Explain how to get intuition in the problem. Yeah, I will talk about intuition also. Okay. So right now, I think that the problem is looking a bit complicated. At least to me, it looked a bit complicated at the beginning because there were so many possibilities. So many things could have happened. So the very first thing I did after reading the problem was directly go to the example test cases and try to read them and just to get some idea. The very first thing they have actually hinted to us is if there is just one element in the string, then the player whose turn it is will lose. Like let's say if it is, by the way, one more thing. This is a standard thing. If in a problem, it does not really matter whether it is Ali's turn or Bob's turn. If the rules are same for both of them, then try to make it a bit generic. Let's say that it is some player's turn. Like this player could have been Alice or Bob, because both of them will have the same rules, right? For both of them, the rules are exactly the same. That is, they will have to, if they can't choose any palindromic cyclic substring, they will lose. Otherwise, this will happen. So, for a player, if the length of the string, let's say it to be n, is equal to 1, then he will lose, right? This is the very first thing which we can observe from the test cases. The second thing is, even though the size is 2, but there are like both the characters are different, then this player will also lose. So if the string was having length 1, then the player was losing. And if the string is either equal to 0, 1 or string is either equal to 1, 0. In both these cases also, the player is losing, whoever is having his turn. Then in the third test case, they are having 0, 0, 0, 1. Let me just come up here and write 0, 0, 0, 1. So initially the idea which I got was that like I did not really knew whether I should choose this as the substring and delete this character, or choose this as the substring and delete one of these three characters. So for me, when I just read this test case, I was not really clear. So what I did is just look up at the test case, and from there I got like I just saw that they have been taking this as the substring and deleting this character. Then you will have three zeros remaining. Like this, I'm just telling what is written in the test case. So what they have been doing is just delete this one first. Then Bob will have to choose this and delete at least one of these characters. Let's say he deletes this one. You will have a 0, 0 remaining. You will delete one of the characters, and then Bob will have a 0 remaining. So Bob will lose, right? In this kind of a case. So here I was not really sure that what would happen. What if, like, what would have happened if I had deleted a 0? So I just tried to think that, let's say, if I had chosen this as a this as the substring and had deleted 0, then in that case, this would be the remaining string. Now Bob has two choices: either delete this one or this 0 by either choosing this as the substring um, or choosing this as the substring. Right. Hope that you are getting the idea. I'm just moving up a bit faster because this is the example test case, which have already been explained here. Right. So um, I think that here deleting this, yeah. So Bob, like for Bob, if he deletes this one, you can just manually check this also that if Bob deletes this one, then in that case you would have 0, 0 remaining and you will take out a 0 and you will win. So for Bob, it does not really make much sense to delete this one. Instead, Bob will delete a 0. So you will have a 0, 1 remaining and you can't really choose anything. So one idea which I was able to get is initially the length of the string is n, right? Uh, yeah, actually before this I got another idea which was very important here. The idea was other than this 0, 1, like other than these things which they had already hinted where a person player will lose, I just tried to think that can there be some other place where the player will lose or not. So like since I had got the idea key I was having three zeros and then a one, I could just choose this as a substring. So I just got the idea that hey, if they like if instead of the zero, basically if you are having three characters, let's say them s0, s1 and s2, and s1 and s2 are equal, or how to explain? Let me just directly tell this. Directly tell what I had observed here. I can choose this as the substring. In case if it was a bit different, if there was a one here, then still I could have chosen a substring. If there was a zero here, then still I could have chosen a substring here. If there was a one here, then still I could have chosen a substring. So I just tried to think about a few different cases and I realized that other than 0, 1, 1, 0, 0, 1, other than these four substrings, each and every time I would definitely be able to choose either something like 0, 1, 0, 1, 0, 1, 0, 0, or 1, 1 at some place. You will never have any substring which does not contain at least one of these four as the substrings of the given string. This is something I observed by trying to think about a few cases. And this is fairly simple. You can also try to do it. Just try to think that if there is any other character ahead of it, in front of it, maybe having a um, 0 here, it will form a palindrome. If you have a 1 here, it will form a palindrome. If you have a 0 on the left, it will still form a palindrome. Similarly for 1. Similarly, putting up a 0 here or a 1 here will also form palindromes. So these are the only four cases where a player can lose. Now, still like the problem is not really that simple. Like we have got to the idea where a player will lose, where the game will terminate. The game will terminate on either like one of these four cases. But on what basis will allies decide what to play? This was the doubt in my mind. So I just tried to think of a very simple test case. That let's say that there are all ones. All the characters in the array are one. Now, if the length of the string is n initially, allies will like whatever string allies chooses and whatever character allies chooses, the thing which will happen is the string will get length n minus 1. You would definitely be able to choose at least one string. After that, the same thing will happen. Like Bob will also have a lot of ones left, n minus 1 left, n minus 1 times 1 is would be coming. So Bob will also choose one of these characters and delete it. And the like on Ali's turn, length was n. On Bob's turn, length was n minus 1. On Ali's turn, the length was n minus 2. On Bob's turn, the length will be n minus 3. So when the turn becomes, when the length becomes 1, whoever's turn it is will lose. And this is fairly simple to compute that if it was Ali's turn on E1, when if n was initially even, then Ali's turn would be on n, like whenever Ali's turn comes, the length would be either n or n by 2, sorry, n minus 2 or n minus 4 or something. Basically, n would always be even. And for Bob, n would always be odd. So, like, since one is odd, it would be Bob's turn, right? Similarly, if n was initially odd, then Bob's turn would be coming up in cases when and the length of the string is odd, sorry, the length of the string is even, and for the length of the string being 1, it would have been Ali's turn. It would have been Ali's turn, so Alice would have been losing. So at the very least, we have got the idea that if all the characters are equal, we can decide who will win. Right? If all characters are even, then we can decide whether Alice will win or Bob will win. We can do this. We have got 4 terminating cases. If any of these is being given to me, I can still identify that who will win or who will lose. And I actually got one more idea. Let's say if 0 is coming up n by 2 number of times and 1 is coming up n by 2 number of times. Then in that case, whatever Alice chooses, Bob can choose the exact opposite of that. Whatever Alice will choose, Bob can choose the exact opposite of that. So that initially 0 and 1 would be present n by 2 and n by 2 number of times. After 2 turns, like let's say if Alice chose a 0, Bob will choose a 1. So that after 2 turns, the number of occurrences of 0 and 1 would be n by 2 minus 1 and n by 2 minus 1. Similarly, it will just keep like it will just decrease in this way. Both of them will decrease 1 1 after every 2 moves, and so on until both of them become 1 1. In that case, whoever's turn it is will lose, right? And we know that when this was the state, it was first Ali's turn, then Bob's, again Ali's, then Bob, again then Ali's, then Bob. So it would be Ali's turn here, and Alice will lose. Alice will lose. So this is the
Sir, but
third observation we have made so far.
hello,
Hello, are you asking something?
sir, but why Bob will choose opposite of Alice?
The idea is, like, to be honest, when I was solving the problem, it felt really intuitive to me that when, let's say that if there is a 0 1 remaining at the end or 1 0 remaining at the end, then Alice will just lose, right? And if 0 and 1 are coming so many times, but they are coming equal number of times, if Bob can maintain that ratio, that basically if Bob can maintain this equality, the number of times 0 has been coming, if Bob can maintain this, then eventually at the end of the day, this 1 1 will come. Like, I'm not really sure how would it feel intuitive to you people, but um, I'm not really sure how to explain it better. In my case, like, to be honest, in my case, I did not really think of all this. It was directly intuitive to me. As I just saw ki if both of these are equal, everybody will just, like, Bob will just try to play the game in such a way that Alice cannot make any progress. You should try it, you will get it. Because that would increase the chance of Bob to win.
Sir, how 1-1 will come? Can you
To be
make
honest,
it
it
dry
comes
run?
randomly. Like, generally, the idea would come randomly unless we get really, really experienced.
Sir,
Yeah.
sir, can you explain by dry run how in last 1-1 will come?
Okay. Yeah, I can do that. Let's say initially the string is something like this, or maybe it can be anything. है ना? We have seen so far that if the string length is, if the string is anything other than these 4, basically if the length of the string is anything greater than 3, in that case, Alice and Bob would definitely be able to choose uh, at least one of the palindromic cyclic substrings, and they will at least get one of the strings. For S being equal to 2, 0 1 or 1 0 is losing, but 0 0 and 1 1 can be played there also. For now, let's see this. Uh, it does not really matter which one Alice chooses. Let's say Alice chose this. Bob can just reduce the other one to keep the frequency of zeros and ones equal. Let's say Alice chose this 0 now. Bob on the next turn will choose this other 0, other one, so that the frequencies are still the same. Again, Alice can choose a 0, Bob can choose the other one. Maybe Alice chose this one, Bob can just choose another 0, right? And at the end of the day, when the string length will become equal to 2, like until now, we knew that as long as the length of the string is greater than or equal to 3, a player can choose a string for sure. But now when s is equal to 2, now it depends upon the string whether the string is having 0 0 or 1 1. Like in these two cases, the player can make a move. But in the case of 0 1 or 1 0, the player cannot make a move. And we know that like Bob could have just chosen the other character to make sure that 0 and 1 are having the same frequency in the string all the time. So eventually you will either have like basically you will have both of them coming up once. As you can see that 1 and 1, 0 and 1, both of them are having the frequencies 1 1. Something like this can happen. So is that what you were asking?
Yes, sir, but answer would be 0, 1 or 1, 0. It would not be
The
0,
answer
0
will be
or
Bob.
1.
The answer will be Bob.
Yes, yes, but the last means the string which will be remaining will be 0, 1 and 1, 0, but not 0, 0 and 1, 1, isn't it?
Yeah, the string would be one of these, not one of these. And that is like we are sure about it because we know that Bob could have maintained this equality. Okay, so I think that at this part, the only thing which might have not been intuitive for you people is
So why we
how
are assuming that there is an equality? Matlab, Alice and Bob are popping out the opposite elements from the array.
yeah, like Bob can do it. Bob can do it to make sure that at last the remaining string would be either 1 0 or 0 1.
So why they are doing like that?
Hmm?
Why they are doing like that?
Like Alice is not the one to decide. It does not really matter whether Alice is choosing 0 or 1. Bob is doing it. And the reason he is doing it is because he wants either 0 1 or 1 0 to be the remaining string. You know that if, like, even if you come up here and see, when n was, let's say, even, and on every move, a character was being deleted till you were left with 1, like until you were left with 1. In that case, Bob was losing here, right? If the game ends when n is equal to 1, Bob will lose. But if when n is equal to 2, either 0 1 or 1 0 could have been the remaining strings, then in that case, Bob could have won. Like, I think that it is still not a good doubt, this one. Like, this one does not really looks like a good doubt. You can just see that Bob can like do the choose the opposite choose the opposite digit to just make sure that the remaining string should be 0 1 or 1 0. This can be the reason why Bob will choose it. Sir, can we just say that if only one character remains in the string, all the characters in the string are same? Yeah, if there is only one character remaining in the string, then obviously it like all the characters in the string are same because there is only one character. Okay, so just for checking, how many of you are with me right now? How many of you have understood this, these cases? The first case was the termination, which we saw from the example test cases where the game will be terminated. Then we realized that the game will never terminate in any other condition. We just identified that if all the characters are equal, basically if the game goes till n is equal to 1, if the game goes from the length n till 1, then depending upon whether n is even or odd, a player will win. And in case if all the characters in the string are equal, then the person having the turn will lose at the end. Uh, if the string is greater than 3 characters, does it really matter whether which character is removed? Yeah, it does matter. We will see it just now. Now the next thing is, you just saw that if the number of times 0 is coming is equal to the number of times 1 is coming, then player is dead lost. Like basically the player is lost, whoever's turn it is. Right. So if at the start, when like first move is gonna be played by allies, if at that time CNT0 is equal to CNT1, then the answer is definitely Bob. Allies will lose, Bob will win here. Hana, we have seen how it will happen. But what if the absolute difference of count 1 and 0, basically if 0 is coming up one more time than 1, or 1 is coming up one more time than 0. In those cases, like you saw that you will lose if this thing happens with you. Now you will try to think that, can I somehow make sure that this happens with my opponent? Can I somehow make sure that this kind of string happens with my opponent? Let's say if the given string is something like this, you can definitely do it. Just choose a character such that the remaining characters will have the same frequency. Now it can happen only if the character with the uh, higher frequency is having just exactly one frequency more than the character with the lesser frequency, which is in this case. Or if you want, you could have written it shortly as count 0 minus count 1, absolute difference of count 0 minus count 1 to be equal to 1. If either these two or this one is satisfied, basically these two are the exact same thing. This and this is the exact same thing. If it is satisfied, then allies can play a moves so that Bob will have this situation. So in this case, you can definitely say that allies will win. Right. I hope that it makes sense till now. We have got it. Like we do have some conditions where allies will definitely lose. We realize that a player will lose if this kind of a situation is happening with him. So we would like to have this situation for the opponent. If it happened with you in the first run itself, you are really unlucky. But if this did not happen, you would like to see if you can make this happen with for your opponent. So the absolute difference between these frequencies should be equal to 1, so that you can make it equal to 0 by choosing up the character with the higher frequency. Otherwise, let us say if it is something like 0 0 1 1 1 1 1 1 1 2 3 4 5 6 7. Yeah, maybe let me just reduce a few of them. Okay, so if it is something like 0 0 1 1 1 1, if the correct if the string is something like this, in that case, like right now n is 6. For winning, like if it is Alai's turn at the beginning and Alais wants to win, he would like to play a move such that the game goes till n equal to 1. He would like to play such a move that the game goes till end and does not really get stuck at 0 1 or 1 0. He would like to avoid it. So for avoiding it, one thing which he can do is try to try to make the string look like this. If allies can somehow make the string look like this, basically having all the characters equal, in that case allies will definitely win, right? So I think it is, if you could think this much, then the next part is really intuitive on how allies will do it. He will just try to reduce the frequency of the smaller uh, character, basically the character with the smaller frequency. He will erase it. on Bob's turn. If Bob removes it, then it is really good for allies. And even if Bob chooses a one, it does not really matter because on the next turn, allies will remove this and the string would be left in this way, from where Bob will lose and allies will win. Right? Does it make sense? Does it make sense that how can allies decide what character to choose for a normal string? But now let's say that if it was something different, if it was something like, okay, somebody is asking me to repeat it again. See, we know if a string looks like 11111, all the characters coming up same, and n is even, then allies will win. This is something we have already discussed so far. We discussed it a while ago. Now the thing is, the actual string might not really have all the characters as ones, but the idea was like when we took all ones, the idea was the game was going till n equal to 1 from n equal to 0. Basically, the game was going till either 0 or 1. One of these strings is being left. Right. Let me take an example. If the string looks like this, maybe, and you chose this larger character, Bob can choose this, and you would be left up with this unwinnable game, a game which you can't really win. Right. This can be other motivation for you to remove the character with the smaller frequency, like whichever feels more intuitive to you. To me, the this one looked more intuitive during the contest, that if I just remove the smaller frequency character, it does not really matter whatever character Bob chooses. The character which is having the smaller frequency will get exhausted first. So the game with this kind of a situation is gonna be identical to the game with this kind of a situation. This was the intuition I got, that you can just try to eliminate all the characters with the smallest frequency so that you will not have any chances of having the game end at 0 1 or 1 0. You will definitely win in this case, right? But what if n was odd? If n is odd, you would like to have the game end at 0 1 or 1 0. You would not like to have the game ending at 0 or 1. Right now we are talking about those cases where these have failed. Like right now, we are only talking about the else case. If you could somehow make sure this happen, then you would definitely do it. So basically, if the string looks something like this, you would definitely take out the larger frequency character to make it equal to unwinnable game for Bob. But what if it is looking something like this? What will you do? Choosing the character with the smaller frequency is bad for you. But the thing is, even if you remove the character with the larger frequency, now for Bob, the game is looking like this. Now, from Bob's perspective, the game is looking like this, where n is even and the characters are not having the same frequency. So we know, like whatever you were playing, Bob would also play the same game since the rules are same for both of you. Bob is also smart. He would just eliminate the character with the smaller frequency, and we know that the character with the smaller frequency will get exhausted first. So eventually, what will happen is uh, you will remove this, Bob will remove this, you will remove a 1, Bob will remove a 0, and you would be left up with all the characters having same, like with same value. So at the end of the day, when n would be equal to 1, it would be Ali's turn and Ali's will lose. So Bob will be the winner. And that's it. Like these are the only cases in this problem. Um, so how many of you are with me? Does it make sense? Like, is the problem clear or is there some problem? Okay, so somebody is saying that we basically try to find out the situations where allies will surely win or Bob will surely win and terminating characters. Yes, exactly. We just try to find out the cases where allies or Bob will definitely win. And like if you know that you will win in this kind of a situation, you would like to play in that way. And I don't really know about it properly right now, about the theory. But if you have studied about game theory, then the problem should have been very obvious for you. Like right now, the things might be looking a bit random to you. That why did we think about this situation that um, whatever allies chooses, Bob will choose the exact opposite, or this kind of things might be looking a bit random to you right now. But if you study about game theory, there is something with grand theory, like a similar name to this. I'm not really sure of the exact name. If you study about it, you can find it on Osako CP book or maybe on CP algorithms also. Things will become easier for you for the next time. What is game theory? You can just search about it on internet. Just search about it on internet. You will probably find a CP algorithms blog. Okay, so shall we move on to the code? Probably we are going a bit slow right now. Can we move on to the code? There are 28 people in Meet and only 2 people are replying. Why?
Yes, we can.
I'm waiting for your responses in chat. Okay, well, very well. So what I did is, let me just full screen it. Yeah, so what I did is, first of all, I took the inputs. Then I calculated the frequency of both the characters in the string. In case if n was equal to 1, you are already dead lost. You can't really do anything. If like for anything above n equal to 2 or something, if count was equal to, if the count of both the characters were equal, then the player was losing. If you want, you could have actually written that if str is equal to 0 1 or str is equal to 1 0, then return false. You could have written something like this, but this case would actually be included in this if condition, that if the count of both of the characters are equal, then you will lose. If the count of 0 is just greater than count of 1 or count of 1 is just greater than count of 0, basically in one move you can make this condition happen for the opponent, then in that case you can win. And in the other cases, if n is even, then you are winning. If n is odd, then you are losing. We have identified that that if all of these conditions had failed, had not happened, then in that case, it did not really matter what the string looked like. The only thing which mattered was whether n is even or odd. In the case of n being even, Alice was winning, and for n being odd, Bob was winning. Okay, so shall we move on to the next problem? The code for this problem is fairly simple. The number of cases we had to form was actually the difficult part. And like the problematic part was this only, that in case if somebody just misses a small case, maybe like he missed this edge case, and you get a wrong answer, then you might just get confused that where did I make a mistake, and might waste up a lot of time. Luckily, in my case, I was able to solve it pretty fast, like fairly fast. I was having a good rank initially. Now this is the third problem, construct XOR. This is also a similar problem. It will also have very many edge cases like the previous problem. But this one is at least easier to understand than the previous one. Cake cutting would be done after it. Cake cutting is actually simpler to understand when I will explain, but to think it would have been a lot more difficult than this one. Like understanding it on your own, solving it on your own is harder, but understanding the editorial is simpler. Okay, so let's start. You have been given two integers n and s. You have to find any array A such that it is having length n. For each AI, like each and every character of the array should be positive. That means it should be greater than 0. The sum of the array should be equal to s. S is the integer which was being given to us. And the bitwise XOR of all the elements should be equal to 0. In case if there are multiple such arrays, then you can print any one of them. And in case if there are no valid arrays, then you can print -1. So when I read this problem, the very first thing which came to my mind is, which many people have actually been writing in the chat also. Let me just write it once here. Yeah, if I want the XOR of the array A to be equal to 0, then each and every bit, each bit should come twice, like should come even number of times. Should come even number of times. Since each and every bit has to come even number of times, S must be even. Because like whether S is even or odd depends upon how many elements are there in the array A which are odd. So if AI is odd, then 0th bit in AI is set, which means like if you want the sum of the elements to be odd, you would need to have odd number of elements which are odd. So basically you would need to have odd number of AI which are having their 0th bit set. And you know that each and every bit must should come even number of times. So even number of AI will have 0th bit set. This is good enough to signify that S must be even. Like I got this idea almost instantly. So if you get S equal to -1, then the answer is simply minus. Sorry, if you get S being odd, either you check it like this or just say S is odd, then the answer is -1. This is directly, like this is something you can instantly say. The next thing is, what if S is like, when you know that S is even, what to do next? Let's read the example test cases here. Uh, okay, example test cases were not really that helpful. I did not really get much idea from example test cases, but I got it randomly. That what if, like, you know that S must be even. I tried to make up two cases, that what if N is odd and what if N is even. Since I wanted the bitwise XOR of all the elements to be 0, I thought of the case for N being even, that whatever characters I put up in the first n by 2 places, I can just place up those exact same characters in the next n by 2 places. Since S is even, S by 2 will be an integer. So I can make sure that these characters will have their sum as S by 2. So if I place something like 1024 here, oh sorry, 1224 here, these are four distinct characters. Sorry, these are four characters elements. Then I can just place 1224 here also. In any order, it does not really matter in which order you put up. So that the XOR of these elements will be 0 and the sum of the whole array will become S. Does this idea look good? Does this idea look good? We got this idea because we wanted the XOR to be 0. So it looked intuitive. Here, if you're picking a character A0 in the array, maybe if you're having 10 in the array, just have it twice so that their XOR will be equal to 0 and their sum will be equal to 20, like whatever the sum is. And so I think that this was fairly simple. Now this problem has become that you have to create an array of length n by 2 whose sum should be equal to s by 2. This is something simple. Just put up n by 2, like just put up n by 2 minus 1. Sorry, yeah, just put up n by 2 minus 1 number of ones in the beginning and then put up a number which is equal to s by 2 minus n by 2 minus 1. This number should be positive. Remember it. This number should be positive. For all these characters, you know that these are positive. These are not violating any of the constraints which we had to make sure. But this might violate it. So you can just check that, hey, since you have n by 2 characters, n by 2 elements, s by 2 should definitely be greater than or equal to n by 2. In that case, you can just have this as your answer. Else, in case if s by 2 is less than n by 2, then the answer, like I just printed minus 1. If you want a proof, you can just try to think of it in this way, that since s by 2 is less than n by 2, it means s is less than n. And if you want to create an array which follows these conditions, every element has to be positive. So each and every AI should definitely be greater than equal to 1. So the minimum sum you will have for the array is n. And since s is less than n, you would never be able to form it. This is sort of a logical or mathematical proof, whatever you consider it. Okay, so is this clear? Like, does it make sense that when n is even, it is really simple to get to the answer? Guys, does it make sense? What about others? Still, only 2 people have been replying. What part do you want me to repeat? I got stuck odd case. Like, we have not even discussed the odd case. So how did you get stuck at odd case? Are you talking about this? N part wala. What if n is odd? We have not discussed that part yet. We have not discussed the part of n being odd. We have only discussed about this part yet. I'm asking that whether it is clear or not. This is the simplest thing you would have in this problem. Okay, so till now it is clear. Great. Now, what if n is odd? This is the only hard part in the problem. What if n is odd? See, the very first intuition you might have is, let's say you took the first n minus 1 by 2 characters, and then you took the exact same n minus 1 by 2 characters here. Then you will have to pick up another character. Let's say you pick up 1, 2, 2, 4, and then 1, 2, 2, 4. Then you will have to pick up a new character. The XOR of all these elements is 0. So whatever character you put up, you will get the XOR of the whole array to be greater than 0, basically not equal to 0, right? So at the very least, this thing is clear that we can't we can't be this smart ki just neglect the, like, just solve this part of the problem independently and solve it differently. It is not solvable. right? What if you say, yeah, um, like if you see, even when n is odd, the goal is still the same. You want the XOR to be 0 and you want to have the sum of those elements to be less than or equal to, sorry, less than s. Sorry, you want the XOR of the elements to be equal to 0 and you want the sum of the elements to be equal to s, which is an even number. Since you want the XOR of all the elements to be equal to 0, it makes up a lot of sense to try to think of having as many duplicates as possible, right? If you got 1, 2, 3, 4 here, you would like to have 1, 2, 3, 4 being repeated so that you won't really have to worry about the XOR, right? At the very least, I think that this thing does make sense, that what we want to do. But if we try to have n minus 1 by 2 and n minus 1 by 2 characters repeating, and there was only one character remaining at the end, it was not possible to have this character having a XOR 0. And like the next thing which I tried after this was, what if I have n minus 3 by 2 characters repeat? After that, I have another n minus 3 by 2 characters repeat, and I will have 3 characters left at the end. Can I somehow make sure that these 3 characters will have a XOR 0? Is it possible to have XOR of these 3 elements, or basically integers, 0? Can you think of 3 elements having XOR 0? In my case, it was instantly in my head that I can pick up 1, 2, 3. They will have their XOR equal to 0. In case if it was not really obvious to you, you might have got it while thinking about random things. You might have not got it really quickly, but if you just try to put up efforts, you would probably get up to this idea sooner or later. In my case, I just got it instantly. And I tried to prove it for me, like just try to see that like just try to um, prove it that this is the best thing I can do in my head. If I'm thinking of 3 characters to be taken at the end, what is the best thing can I do with them? I just got to the idea that uh, I will pick, if I pick up 1, 2, 3, then my new s, let me call this as s dash, will become s minus 6, and n dash will become n minus 3, right? For the remaining array. And now if you see, this n dash would be even, n dash is even, and s dash is still even. And if n dash and s dash are even, then we know how to solve it. We have just figured out how to solve it. So we can just solve it in the exact same way again. Now, when is this n dash being even and s dash being even failing? The only case where it can fail is if s is less than n, right? So you would like to have this s dash being as large as possible. And if you see, there is no better thing you can do here to remove smaller number from s. You can try to think about it. You will see that it does not really work out. So we have got to the idea that, hey, if n dash is odd, then make the problem, sorry, if n is odd, then break down the problem into 2 parts. Pick up the first 3 characters as 1, 2, 3, and for the remaining characters, let me call them as n dash characters, which is an even number. The sum here is 6, so the sum here should be as s minus 6. Actually, these are n minus 3 characters, which is even. The XOR here is 0. The XOR here should also be 0. This is a problem which we know how to solve. So it has become a lot simpler for us how for approaching this problem. And to be honest, at this point, I thought that I have got the solution for the problem. But there was one important part left in the problem. Actually, the toughest part of this problem, I think. I think that this is gonna be the toughest part. That what if n is equal to 3? Earlier, I was not able to think of this case on my own until I looked up at the test cases. That is this 3 comma 14. For this n equal to 3, s is equal to 14. My idea of putting up 1, 2, 3 at the beginning and then having the remaining zero number of elements to have the sum of 8 will not really work out. So I will have to think of something else. And then I just tried to figure out that in this case, I will just have to pick up 3 characters. Like basically, I will have to pick up 3 characters whose sum is equal to s, and the XOR of these characters should be equal to 0. Like right now, you know that n is equal to 0. And by the way, there was one more thing. N equal to 1 is also odd. N equal to 1 is also odd. I got this idea when I just was thinking about n equal to 3. I got the idea that what if n is 1? In this case also, the answer should be like when n is 1, the answer is easily -1. Because whatever you put up, you will never be able to have this or as non-zero. Now for the case of having 3 elements whose sum is equal to s and the XOR being equal to 0, I tried to think of 6, like the element 6, which I was initially forming in the bitwise form, and the characters which I was picking up for having this sum and bitwise XOR to be 0 were actually 1, 0, 0, 1, and 1, 1. This is, I think, intuitive that all the characters should be having even number of frequency. I got the idea that what if I just divide it in such a way that each character will have, sorry, each bit which I take will have a frequency of either 0 or 2. I can't even do anything else. Like if you see, you can't do anything else anyways. Now, this was my motive. I just got this idea that if I want this bit to be set, in that case, I would need to have two of these elements A0, A1, and A2 to have this bit set. And if I want this bit to be set, then I would need to have two of the elements having this bit as set. This is the idea which I got. And from there, I just made it a bit generic, that whatever string I have, I know that if this bit is set, then at this place, you must have two people having the bit set. So let's take one of them. Let's take it set in A0. Since this bit is set, you would need to have a bit here. Since this bit is set, you would need to have a bit here, and so on. Basically, I divided the number by 2. I right shifted the number by 1. Then for A1, I just took this bit as set and everything as 0. And for A2, I just took this bit 0 and every other bit as it was in A2. So the basic idea is the sum of the um, like for sum of all the bits, if you just take up the sum of all of these 3 bits, it would actually be equal to this. These will basically, if this bit is 1, you are having 1 1, you are having two numbers with this bit as set here, so that there will be a carry which will come up here. Similarly, when this bit is set, you are having two numbers, so that a carry will come. Similarly, for this number, you are having two numbers, so a carry will come. Similarly, here a carry will come. Similarly, for this, a carry will come. You made this thing sure, and every bit is having either 2 or 0. Like this is coming up 2 times, this is coming up 2 times, 2 times, 0, 2, 0, 2. So these OR would also be 0. Now there can be different ways of picking up these three numbers. This is one of the ways which, like, this is the only way which came up to my mind. And I think that this n being odd wala part can be taken a bit more simply if you guys had been thinking. Like if n is odd, you could have said key from S, just basically if n is odd, then except the last three characters, just take up all these characters as 1 1 1 1 1. And then for the last three characters, this is now equivalent to having n being equal to 3 and this like n dash being equal to 3 and s dash being equal to s minus n minus 3. Right. And for this part, we have actually here decided how to get the answer. So it's up to you in which way you want to solve. You don't really need to do it in this way. It's up to you. Okay, so now let me read the chat once. Oh, same. Please repeat this part. Can you please repeat this part? The last one. The last case works for all cases, right? The last one, like this case which we have been writing up here is only like specifically for n being equal to 3 and s like right now we have not discussed the part where this will fail. This thing which you might have noticed is like I have not really told you about the way I came up with this idea. This is something I randomly came up with. I just tried to think about some random stuff and this came up in my mind. One case where it was failing is if there was only one set bit, then you could have got this like the bit on just on the right side being set in A0 and A1. But what about A2? Where like which bit will you keep set in A2? There was no way for it. There was no way for having A2 being set at any place. So this was the only case where it was failing. That what if there is only one set bit in the given number S? In that case, the answer will be -1. Okay, so now let me just summarize the problem which we have seen so far. If S is odd, then the answer is simply -1. If n is even, then we divided the array into two parts such that the sum of the first n by 2 elements is s by 2 and the sum of the next n by 2 elements is s by 2. Here we could have got a problem that like here we were having two cases. If s by 2, or basically you can say that if s is less than n, then the answer was again -1. But in the other case, the answer was actually this array. In the else condition, okay, let me just write it as else if. In the else condition, if n is basically odd here, in that case, you are having a multiple cases. That what if n is 1? The answer is no. Like the answer is -1. You can't really do anything. The if n is equal to 3, for this we formulated a case. For this we formulated a case like um, if number of set bits in S equal to 1, then the answer was coming up to be -1. Else the numbers were coming up to be equal to S by 2, and the other two numbers are chosen in such a way that their XOR is equal to S by 2. Basically their or XOR, whatever you say, is equal to, yeah, their OR should be equal to S by 2 and their XOR should also be equal to S by 2. Both these things should happen. For which I just said ki S by 2, since set bits in S is greater than 1, so S by 2 will have at least 2 set bits. I took the MSB here. Like one of the numbers I took was having the MSB of S2, and the third number was having S minus um, this number and this number. If I call this as V0 and call this as V1, then S minus V0 minus V1 was the third number. I have not really told you about the intuition of getting to this idea since I just randomly got this idea. Though it can look intuitive now, like to me now it has been looking up a bit intuitive, but it's like even if I tell you in that way, it might not really look that intuitive to you. And by the way, we might have missed some of the proofs, some of the mathematical proofs that actually we have not come up to that part yet. We have seen these things. If n is not 1, n is not 3, but n is odd, basically in the else condition, if it will come to the else condition if n is odd, we are just saying that divide the array into two parts, like the first part having just 1, 2, 3, and the second part having n dash being equal to n minus 1 and s dash, sorry, n minus 3 and s dash being equal to s minus 6, and solve it. So this is something also doable. And in case if we can't solve it, like in case if s dash is less than sorry, n dash, then the answer is no here, -1. Else the answer is coming up here. So you see that there were so many cases which we have created. And you might have a doubt that here at this place, is there some guarantee that we could not really have any other way of forming the answer? So I knew this thing that I have not mathematically proved it, but I just gambled by submitting the problem. So to be honest, I have not proved it myself. If you want, you can look at the text editorial. Probably they would have included a mathematical proof that if we don't get our answer, even after all this, then there is no such possible answer. For the proof of that, you can refer to the text editorial by Codechef. But for the other things, I believe that everything has been discussed here. Can you just explain the n equal to 3 part of getting numbers? Okay. So for the n equal to 3 part, you want to have a1, a2, a3, basically, sorry, a0, a1, a2, three numbers whose sum is equal to s and their XOR being equal to 0. So if a number is like random, I'm just taking a random number for now. If it is looking something like this, since you want the sum of these numbers to be equal to s, and like very first thing is, since the XOR should be equal to 0, you know that in a0, a1, a2, for this bit it is obvious like that you must have it as 0, because even if you keep one number as 1, you will have to pick up another number as 1, otherwise these or condition would be unsatisfied, and if you keep up both of these ones, then it will have a carry on the left hand side, so basically it would also be a problem. For the next number, since you want a 1 here but you did not have a 1 anywhere here, so you must have two of these three numbers having the bit set, and the third number must not have the bit set, otherwise these OR will not be equal to 0. So you will just have to pick up two numbers. Let's say that we picked up these two numbers. You can pick up any two random numbers. Then again, you want a 1 at this place also, for which you would have to pick up two ones here. Let's say I picked up these two, or maybe I picked up these two. It's up to you in whichever numbers you want to pick. The main important thing is that their sum should be equal to 2 here, so that there is a carry on the next place. And this thing will happen till the last place. You will have to have a 0, 0, 0 here, similar to what the, like, as we had a 0, 0, 0 here, similarly you will have to have a 0, 0, 0 here. Otherwise, you will get a carry there, which we don't want. Since you want a carry here, you will have to pick up two numbers with 1 ones. You want a carry here, so you will have to pick up you will have to have two numbers with set bits. You want a 0 here, so you just have 0, 0, 0. You want to have a 1 here, so you might like to have something like this. Anything is fine. Now, how will you decide what should you have as a0, a1, a2? There are two things you have to make sure. First is this thing should always happen. This condition should definitely not be violated. And at the same time, we want one more thing. The total number of set bits in A1, A2, and A3 should be greater than 0. Basically, the values of A1, A2, and A0 should be greater than 0. And now, like, this is sort of random. Like, we have just chosen two numbers randomly here. Similarly, at every place. For which number should we have as having the set bits? Right. We will try to figure out a pattern for that. And you might be able to figure out one more thing, that let's say if the number looked like just having this bit as set and all the other bits being 0, then all these numbers would have been 0. So you would have got only two set bits. So in that case, you definitely can't really have all the three numbers having at least one set bit and uh, not violating those constraints you have. So does it make sense that if the number of set bits in S is equal to 1, then the answer is no. Then answer is -1. Does it make sense now? Initially, I had not really told you about this intuition, because I think that it might still not be really intuitive for a lot of people, that how did I approach the problem from left? Why did I think about it in this way? And these things came up in my mind randomly. Okay, the next thing is, how will you decide the values of A0, A1, A2? Will you just really go bit by bit and randomly decide? This is something you can do. Though you will have a problem that what if one of the numbers just does not get the set bit while distributing the bits randomly. The idea which I got is, like, for simplicity, since I know that these bits, like, here I must have some set bits here. I got this idea from, by the way, I got this idea from um, S being equal to 6, which was coming up to be 110, and I was picking 1101 and 10. I just thought that, hey, let's pick up one everywhere here. Like, let's have, whenever you need to forward a carry, you need to have two set bits at some specific position. Let's have A0 containing all of them. Now you will have to decide for every bit, either put it in A1 or A2. For that, I said that, hey, for the MSB, let me put it at A1, and every time after that, I can just put it at A2. So that I will make sure that every number will be greater than 0. Each and every number is greater than 0 here. And these OR of all the numbers is equal to 0. And the sum of all of these numbers is equal to S. I got this idea from here. Okay, so I think that this is now clear. This part is now clear. This part is really trivial. This part is trivial. This part is also like not so hard. Similarly, this part. And for the else condition, distributing it in this way is also not so hard. Like, you must have got it. Maybe thinking about it might have been hard for you during the contest, but understanding is easy. And for this remaining part, yeah, this is also easy. Like, this is now just the even wala part, so probably you can understand it on your own. So is the problem clear now? Shall we move on to the code? Okay, let's move on to the code then. I'm not sure if my code is clean or not. By the way, this is a function for MSB. I just have it in my template so that I can just copy and paste it during the contest. For each and every test case, I'm first of all taking n and s as input. These are the trivial cases, that what if n is 1 or s is odd or n is greater than s. In all these cases, the answer would definitely be No, so I'm just handling them here. After that, in case if n has to be 3, um, yeah, sorry, if n is 3, in that case, first of all, I'm having the trivial case that the number of set bits should be at least 2. If it is equal to 1, then the answer is no here. Then I have created, this is my answer, like this is my answer array here of size 3. The first number is nothing but s being right shifted ones. If you see a0 is nothing but s by 2 or s being right shifted ones. For finding m1, sorry, for finding this a1, I'm just having the msb, like whatever is the msb of a0 that is set in a1. That is what I've been finding here. And for a2, it is nothing but s minus a1 minus a0. Or if you wanted, you could have been a little fancy. You could have said that it is s zor a1 zor a0 zor a1. No. That like sorry, it won't work. You could have said that it is a v0. Yeah, you could have written it as v0 zor v1. You could have written it in this way. Yeah, somebody said in chat that we are happy with simplicity. That's why I just wrote it simple. Otherwise, I would have been willing to write the fancy way. Okay. In the other case, if n is not equal to 3, like other than writing it, coming up to this part, other than writing the part of n being even, alag se, like first of all, writing this part that what if n is even, and then writing that part again here, what I did is I just wrote the code in a bit different way. You don't really have any obligation of writing it shortly. You can just have repetitive code. But I wrote it in a way that if n is odd, then I'm just putting up 1, 2, and 3 at the end of the array. And for that, I have already reserved 3 positions and I have reserved 6 from S. And then I have been just writing up the code for even number. And once I'm done with the even numbers, I think, yeah, this is correct. Yeah, this is the code for even numbers. And after that, at the end, in case if flag is true, basically if n was initially odd, in that case, I'm just pushing up 1, 2, and 3 at the end of the vector and then returning the answer. And here I have just printed it. And obviously, this could have been written a bit shorter. Instead of returning empty arrays every time, I could have actually returned vectors with -1. Again, you don't really have to do this. This is just something you could have written to make your code look a bit cleaner at this place. You could have just simply said here, iterate over this result. And obviously you can remove them. So the code is just looking a bit cleaner. It does not really matter much. And I would like to go back to the original code. Okay, so does anybody wanna ask something? I would just read it in a bit in a while. Yeah. Okay. So for n, I just considered 1 minus 2 and then divided it as 2. Yeah, Akhilesh, what you have done is also correct. Okay. So let's move on to the next problem. This is gonna be the last problem we discussed today. So if you want, you can read the, obviously you would have to read the problem statement on your own. I'm just gonna discuss about it in brief. The PCD has already been quite long now. What it says is there is a cake. This is a cake. It has some positions numbered from 1 to m. 1, 2, 3, 4, 5, 6, 7, 8, something like this. Here m is equal to 8. And there are some layers of cream. I think it was the word they used was cream. Yeah, by the way, at these places, they have placed cherries. Some cherries are being placed at these places on the cake. And there are some flavors, like something like this can happen, that there is a cream or like whatever for a flavor. From 2 to 4, we can call it as from 2 to 4, there can be a flavor. Similarly, there can be a different flavor from 3 to 5. There can be a different flavor from, let's say, 4 to 2. Anything can happen. 3 to 5, 2 to 4. Similarly, something like this can also happen, that there is a flavor from 7 till 2. There is a flavor from 7 till 2. Right. We will be given these arrays. We will be given an array of the flavors. The first position will tell from where the flavor has been started to be put on until where the flavor is there. So if you have been given something like 2, 4 or 7, 2, it means that there is a flavor from 7 to 2. Or 2, 4 means that there is a flavor from 2 to 4. Now what you have to tell is, if you cut the, yeah, one more thing. This is the center of the cake. If you cut the cake in such a way that the cut passes through the center of the cake, basically the cut you make should be a diameter, then how many, like what is the maximum number of flavors you can have coming up on both the sides? Basically, the flavor should come up in this half of the cake also and this half of the cake also. So if you take an example of having a flavor like from here to here, and you make up a cut like this, in that case, this blue flavor will, like this blue flavor is coming up here also and here also. This is coming up in both the places. So this flavor would be counted. We have to tell the maximum number of flavors we can have if we choose that cut optimally. So this is the problem. Is it clear? And yeah, there is one more condition, that we cannot make a cut through this cherry. A cherry should not be harmed. Like, let me just write it, a note. No cherry should be harmed. In making of the problem or solution on anything. Like the disclaimers, we see that no animal was being harmed, similar to that. Okay, so the basic idea which I had was, let us say that there are m number of, initially I just took m being given. I just initially took as m being given. The idea which I had was that if there is a flavor coming up like this, no matter what cut I make, whatever cut I make which is passing through the center, this flavor would definitely be coming up on both the sides. Why is that so? Because this flavor is having more than, like, this flavor is actually having half of the circle being covered. And since I cannot choose this diameter, other than this, whatever diameter I choose would definitely cut this flavor. So the basic idea was, if the length of the flavor is greater than or equal to the half of it. Basically, if I just say that it has been covering up 2 blocks, let me call these things as blocks for now. If it has been covering up 2 blocks, that this is the first block and this is the second block out of 4 blocks. If it is covering up more than half of the blocks, then it would definitely come. This is something really intuitive and common sense, like kind of common sense. So for I can just count the number of such I can just count the number of such flavors. I just created a variable with name over being equal to 0, and I just incremented whenever I saw this kind of a flavor. For the other cases, actually the reason I came up with this idea was something different. I would show you that why did I come up with this idea? Why did I really create a new variable? I will tell you about it. First of all, initially just let's try to solve the problem in a brute force manner. Let us say you have some cherries here. There is a flavor from for now I would not really color the circle. I will write the flavors on the left. If there is a flavor from 1 to 4 and there is a flavor from 2 to 5, let's say, and there is a flavor from 2 to 4, there is a flavor from 1 to 2 and so on. The thing is, you can just find out the number of flavors which are coming up here, the number of flavors which are coming up here, the number of flavors which are coming up here, here, and so on. Can I say this? Actually, there was one more thing which I wanted to discuss. This thing had been intuitive for me in the first go when I read the problem, that if there are even number of cherries and I am having a cut passing through this point, then like since it has to pass through the center also, it will pass through this like this block also. The blocks which are on the opposite side would have the diameter through them. Basically, if the diameter is passing through this place, then it will pass through this also. But in case of odd numbers, it was a bit different. In case of odd numbers, if there is a like if there is a diameter passing through this block, it might actually pass on through this block, or there can be some diameters which are passing through this block, but at the same time with this block. So you see that in case of odd numbers, for a specific block, you can have multiple different diameters. This is another thing which came up to my mind. Right now, we are having just some random ideas. We will connect those dots later on. But right now, we are just having some observations and some random ideas. So this is the one idea which I had. Definitely, the odd case is looking harder. The um, the the solution for odd m is looking harder. If m is odd, then it is complicated. But unfortunately, I will have to solve it if I want to submit the problem. But for now, we will consider only m as even. Let's try to first of all solve the problem when n is even. Sorry, n is even. I've written it odd by mistake. Now, let us say that there is a block. Sorry, 1, 2, 3, 4. Let us say there is a flavor from 1 to 2. There is a flavor from 2 to 3. There is a flavor from 1 to 3. There is a flavor from 2 to 4. And that's it. And I want to find out my answer. So can I say that if I just figure out the number of flavors in each block, let's say I try to figure out the number of flavors in the block from 1 to 2. There are only like 1 and 2. There are only 2 blocks, right? So 2 blocks are having this. The block 2, 3 is being covered in this name, in this in this, and in this. It is being covered in 3 places, right? The block 2, like 3 to 4 is being covered only here. So it is covered in only, let me use the blue pen. Yeah. So it is covered here in 2 times only, 3 times, 1 time only. And the block 1 to 4 or 4 to 1 is not being covered anywhere. So it will be 0. Let me just make, it's fine, I think, for now. Then can I say that the answer would be, like, if my final answer goes through this block, then I know that the other block would be this. So can I say that there will be 3 flavors which will be included? Can I say that 3 flavors will be included here? Similarly, for this, can I say that 3 flavors will be included? For this, can I say that 1 plus 2, 3 flavors will be included, and so on? So can I say that I will go on for each block, for each I, calculate the answer? Let's say I just calculate it in curve. Basically, I can just say that answer is equal to max of answer and whatever answer I calculated for the block I. That will be my answer. At the very least, this looked like what is gonna happen. But then I realized that what if there was a block from 1 to 4? Let's see what will happen if the block was from 1 to 4. It was, yeah. In that case, things will look like this. I'm getting the answer 3. But should the answer really be 3? I'm having, sorry, the answer is coming up to be 4. Sorry, I have not really written it correctly. It was supposed to be 2 here. Yeah, I just got confused that the answer should be 4, but it is not coming up. Yeah. Now I'm getting the answer 5. Right? I'm getting the answer 5. Should the answer really be 5? I don't even have 5 flavors here. I'm not even having 5 flavors and my answer is coming up to be 5. Is it possible? Can you identify the mistake? The mistake is this flavor came up in this region and in this region, in both the regions. I calculated it twice. I considered it twice. Can I somehow avoid this? The answer is yes. The observation which we had earlier, that if there is some block which is covering up more than half of the area, then that is bound to happen. Like either that guy will happen in this or in this, but it would definitely come. And that is like, it is the person which is causing me trouble, right? It is causing me trouble as well. So what if I just ignore it? I just increment the value of my over variable and don't include it in these variables. So here my answer should come up to be 3, either like this or this. My answer is coming up to be 3. And at the end, just add the over variable, which is here 1, and you will get 4. At the very least, this looks intuitive. Okay, so you want me to repeat the part? Can you actually pinpoint the part which you want me to repeat so that I just like 2 times? Okay. See, this flavor 1,4 was like is coming up in this region, right? It is coming up in this region. When we had been counting up the number of flavors per block, this flavor was being counted in this block also and in this block also. So it was contributing 2 to our answer. Like this 3 had become, like this 2 had become 3 and this 1 had become 2. So the answer was coming up to be 5, which is not even possible since we have only 4 flavors in total. Right? It is actually causing me trouble. So what we can do is just remove it from both the places and consider it differently. If there is any flavor which is covering up more than half of the area, it will definitely, like if there is any flavor which is covering up half or more than that, it will definitely come up in each and every block. Whether I choose this block, I will have it. If I choose this block, I will still have it. If I choose this block, I will still have it. है ना? Okay, so is it clear how will we solve the problem for m being even? Okay, really cool. Now the part for m being odd is not so different. The only difference we have got so far now is like for every block, you're not having only one choice. You are actually having two choices now. Yeah, if this is the center, then there is one diameter like this. There is another diameter like this. For each and every block, I'm actually having two choices now instead of having one choice. So um, I can actually do the exact same thing as I was doing earlier. Like in case of m being even, I was calculating the answer for each and every block, and then I was deciding that if I choose this block, if I consider this block being coming up in the diameter, then I was having only one choice, which could have come up as the diameter, like the other part of the diameter. Here I will have two choices. So I can just say, yeah, if I consider this block, let's say that this is my block I, then and let's say that this is block J1 and this is block J2, then answer of I will be equal to the maximum of, actually, let me call this as just answer variable, a normal answer variable. Then it will be equal to maximum of, if I keep track of the number of uh, flavors which come up in the block in variable CNT I telling me the number of flavors which are coming up in this block, then answer will be equal to the maximum of uh, count of I plus count of J1, and similarly for J2, like the exact same thing for count of J2 here. I can just run up this for both of them one by one, and everything is exactly the same. The only difference you will have now is um, how long should the flavor be. Like if there is a flavor having this much length, which is coming up to be 1, 2, 3 length. In that case, there is a diameter, which does not have it. So here, instead of having, actually this is also same. Like earlier also we just used the shielding. From m being even, the only differences will be in this thing only, that you can have diameter in two ways. So answer, like not answer, yeah, while deciding which part is greater than half of the length, um, earlier you were just checking if the end minus start is greater than equal to m by 2 or not. This time, in case of odd, you will check whether e minus s is being greater than m plus 1 by 2 or not. In flow division, obviously. In C++, by default, this is flow division. If you are writing it in seal division, then you don't even need to write it like that. Just write it in this way. Nevertheless, it is something simple. Okay, so I think that we have discussed the most of the part. Now the only part you might have doubt in, which is the conceptual thing, is how will you find out the number of flavors which are having this block in themselves. So for doing it, it is something simple. Let's say if there is a flavor from 1 to 4, it is like, just imagine if it was not circular, if it was a normal array, and you were being given some queries multiple times that increment the values for all li comma ri, then what we can do is just use a difference array, like difference array or partial sum. Multiple people, like different people give it a different name. I just call it as difference array. What we can do for that is just say our count of li being incremented and count of ri being decremented. So it will become 1, it will become -1, and at the end just take the prefix sum of this array. So like at the end of the day, it will be equivalent to if you had just updated all the values one by one. Now I'm not really explaining on how difference array works out. You can actually find out a video on TLE Eliminators also for this. If you just search difference array TLE Eliminators, you will find out a video created by Piyan Shakarwa. So I believe that you can just study about difference array on your own, or just check out that video. So similar to that, like similar to difference array, we can just implement it here also. The only difference is that in the normal difference array, the queries are from L to R, where L is less than equal to R. Here the queries might be in a way that L is greater than R. Like if L is greater than R, then you have to update all these values. So for this, what I did is I incremented this position, that this is count L by 1. I decremented this, like I decremented here count R by 1, and I incremented the count 0 by 1. This is how I kept track of it, and I think that you can also keep track of it. Actually, I'm expecting that if you're coming up to this problem, like for understanding the main idea behind the problem, it's fine even if you are a pupil or specialist. But for implementation thing, I'm expecting that you would be something like an expert if you are actually implementing it. I'm not really explaining it with the perspective of a newbie attending it. At least for the implementation part, I'm not explaining it in that much depth. And how will we check the cuts? The blocks will be cut. Actually, what you can do is, I think that you are just asking that if, like for a block, you want to find out which other block would be cut across, like along with him. How will you check out that thing? Is that what you're asking? Basically, you are asking the values of J1 and J2. So if you notice, in case of even number, it was the exact opposite of it. Like it was I plus m by 2 mod m, the exact opposite guy. If this is coming up between 1 and 2, then the other guy was coming up between 3 and 4. In this case, if you let's say number it 1, 2, 3, 4, 5, 6, 7. So for the block which is having number from 1 to 2, the blocks which are coming up against it are coming up from 4 to 5 or from 5 to 6. So for a block starting from 1, the other two possible blocks are starting from either 4 or 5 when m is equal to 7. If you see m by 2 down, like floor is equal to 3.5 floor, which is 3, and m by 2 seal is equal to 4. And if you notice that here you are just having starting like this I plus m by 2 floor, and this is nothing but I plus m by 2 seal. I think that you got the idea. Now again, this is something we just calculated it. We just found this idea by random stuff. We just thought of some random example where we try to manually check what will be the answer. From there, we got some idea. Now, the next step which you can do is either just prove it in your head by just looking at it, that does it make sense or not, or just try to create another example and verify it in a few examples. Do any of that, it is fine. Okay, so I think that this is enough for this problem. Shall I move on to the code? And this is possible that I might have just like there might be some more things which I have not proved, like the things which I did not prove myself while explaining, while solving the problem. For that, I do recommend checking out the text editorial. I believe the text editorial would be a lot better than the PCD here because the problem is quite ad hoc. So I might have missed some case or might have missed some proof which should have been mentioned. So for that, text editorial is highly recommended. And even if you attend a even if you attend a PCD, and I don't say to check out the text editorial, it is still recommended. But today I'm highly recommending it. So let me show you my code. The code for this problem was quite simple. I'm first of all taking m and n as input and the two arrays as input for each and every test case. Then I'm having this count array, which is basically the difference array right now, and a variable over, which will keep track of um, the number of flavors, which will definitely come up in all the cuts. And here I'm just checking up if the flavor is actually covering up more than half of the um, if it is covering up half of the circumference of the circle or not. I'm just checking this part, checking this thing here. After that, I'm checking if s is less than equal to I, which is like here it is. Yeah, which is the normal case of difference array, which is the normal case of difference array. So I'm just using the normal difference array way. In the other case, which is not really that common, what we are doing is just implementing it in a different way. Now, if you know about difference arrays properly, then this should probably not be hard. Since I have to increment all these values and not really change anything here, I have been incrementing count 0, 0 so that all these values would be incremented until we come up to this part. Now +1 and -1 would have occurred. So for these people, nothing will change. And since you will increment it here, all these people would be incremented. So this is how this code is working. Maybe I can write it here. After that, I'm just creating the prefix sum array of this count, which was a difference array, so that I get the actual values of the blocks. And after that, I'm just running up a for loop. Now, if you want, you can run up different for loops for even and odd cases, or if you want, you can just run up this normally. When m is even, I plus m, basically this m by 2 float division and this m by 2 seal division will be the same. So it won't really make any difference. Like it won't really cause any trouble for us. And that's it. So I hope that for those who have been attending the video on YouTube, if the video helped you in any way, then please consider liking the video and subscribing to the channel. Thank you for attending the video and bye bye.